Welcome to our session on sustainability by design. Due to a well-known nanoparticle, we have to do this digitally, and I hope you can join us well, and you're well connected, and I hope you're doing well. The pandemic has not changed the EU top priority to become the first climate-neutral continent on the planet Earth. The European Green Deal remains the overall policy objective for all we do. This means putting sustainability at the core. The aim is as simple as ambitious. It means nothing less than transforming the EU's economy towards sustainability. We know from the Eurostat report on sustainable development in the EU, if you haven't had a look at it, please do it. It's a treasure of data on how the EU performs in reaching the UN sustainability targets. So from this report, we know that the results under the target responsible consumption and production, the results are mixed. We see a stagnation of the material use rate, a growth of waste generation, and a slight growth of consumption of toxic chemicals. And this is the background for this session and the idea of sustainable by design. It is about integrating safety, circularity, and functionality of materials and products. It is about embracing the economic, environmental, and social pillars of sustainability. It is about building on the remarkable strengths Europe has in material science and chemistry. And it is about maximizing the opportunities offered by the materials and chemicals industries. Today's event is a starting point. I am really delighted that prominent experts, researchers, actors turned their attention to the topic and share their insights and perspectives. Following from today, we will engage with all stakeholders in defining the criteria and the tools to be used for sustainable by design. As a contribution also to the forthcoming chemicals strategy for sustainability, we will prepare a program on sustainable by design under Horizon Europe. So I'm very grateful. Thank you, Xenia, for moderating this session. With your outstanding knowledge in chemistry and your work in the European Environmental Agency, you are perfectly placed to bring us to new horizons. So I hand over to you, Xenia, to moderate this session. Thank you.
Thank you very much, Peter, for setting the scene of why we are here today and what is the expected outcome. I should start by saying that during the session, we welcome you to go to slido.com and use the code at RI20, where you can write your questions. If time allows, we will take a question or two, but the rest amongst the most pertinent questions and popular ones will be collected to inform the further process. And we will also reply to them at our website. You will see the link on the right side now, I'm told. But with that, I think we are ready to start this exciting session. And I'm very pleased to welcome Professor Joel Tigner. He comes from the University of Massachusetts Lowell in the US, and he's also director of the Lowell Center for Sustainable Production. Joel is one of the world's leading experts in green chemistry and safe and sustainable by design, and has for more than 20 years not only developed green chemistry principles, but also helped business and regulators to apply them in practice. So can we please have the slides of Professor Tigner? And then please, Professor Tigner, the floor is yours.
Great, thank you so much, Xenia. Thank you to Dr. Droll and to the organizers for inviting me to be here. Can I have the next slide, please? I'm going to take a very high-level perspective on what is needed to build a research and innovation program to advance safe and sustainable, or sustainability by design. My perspective is informed by the many roles I play as an academic, a researcher, and as a practitioner in the field. So I think about safe and sustainable, or sustainability by design, from an education and basic research and development perspective as an academic. I run a business network called the Green Chemistry and Commerce Council, which works with companies along the value chain to bring together the needs for more sustainable chemistry and the applications for that with innovation policy. I co-direct a center called the Massachusetts Toxic Use Reduction Institute, which works with companies in Massachusetts to support the evaluation and adoption of safer chemicals and materials, particularly supporting SMEs. And lastly, I helped form a group called the Association for the Advancement of Alternatives Assessment, which is a multidisciplinary scientific body that's working on developing the science and the practice of alternatives assessment that supports more sustainable, safer materials and chemicals. Next slide, please. So if I think about it, right, if we think about the high-level approach, what we need to do to drive research and innovation and application of sustainability by design, the first step, and an important critical first step, is a coordinated, integrated policy and program approach. It needs to involve multiple agencies. It needs to have a coordinated mandate across those agencies, and it needs to be able to create a clear, coherent, and directed blueprint for action. A program needs sustained funding and sustained coordination. It needs clear connections to the regulatory demands and the sustainability priorities that would provide both the drivers but also the oversight of those new technologies. So it needs a clear connection between the regulatory or the policy needs and the R&D needs, but it needs to have a clear structure as well for oversight and evaluation of those technologies. It needs to have a clear connection to the member states and the member state level programs so that there is a clear coordination as well as synergies between programs. So you're building a much bigger whole by the parts of that whole. Lastly, there are examples here about the bioeconomy. Much of the work on circularity and renewable energy shows that kind of blueprint, coordinated approach to solving a sustainability need through research and innovation. Next slide, please. In the United States, we've been working to get passage of a bill called the Sustainable Chemistry Research and Development Act, which provides that kind of overarching program approach to sustainable chemistry research and development. It starts with the White House creating a blueprint for action that brings together different government agencies to solve sustainable chemistry challenges and develops a set of actions moving forward, including first defining criteria and a definition for sustainable chemistry. So we need a clear approach, and this is the model of a clear approach that then sets in motion the various actions and activities that lead us towards this research and innovation approach. Next slide, please. So underlying that blueprint for sustainable by design or sustainability by design, we need a clear connection. It can't just be an R&D program distant from the needs of business, technology, and society. So it needs to have a clear solutions focus. It needs to solve clear needs in society and clear actions. It needs funding that supports not only research and development, but it also supports the development of tools to evaluate or develop new sustainable by design materials and chemicals. It needs support for commercialization. It needs support for being able to evaluate the efficacy and the success of such programs and the materials or chemicals that come out of those programs. It needs to not only have R&I, but it also has to have programs to support adoption. A new chemical or material that's sustainable by design is not a successful one unless it's adopted across industry. So it needs both technical support and efforts to bring together that value chain to understand what the technology needs are, what the challenges are, or the barriers to adoption, and how to overcome those barriers. And then demonstration, showing the validity and the viability of those options. There needs to be clear criteria, metrics, and tools to evaluate whether those technologies are safer and sustainable so that we can co-optimize attributes and minimize the potential for trade-offs between those attributes. There needs to be clear investments for incentives for investment in both business and industry. There needs to be rewards and incentivization for investors and businesses. And then lastly, we need to ensure that current professionals and a future generation understand sustainability by design. They have the training and the skills necessary to design the safer, more sustainable materials of the future. Next slide, please. This is just an example of a project we worked on for DG Environment to develop a chemicals innovation action agenda that has many of those ideas of a blueprint to guide the transition to safer chemicals and technologies. You need clear goals, you need clear actions, and you need those to address those underlying challenges or barriers or systems conditions that have to happen to enable sustainability by design to occur. Next slide, please. So ultimately, we need, for such a program to grow, to be successful, it needs clear leadership, sustained resources. Again, the blueprint is a key starting point, but it needs leadership and it needs sustained resources to implement such a program. It needs to really create a collaborative innovation community that brings together everyone, where everyone from chemistry professionals to business professionals to industry to NGOs to the R&D community all see a place for themselves in this program. It needs to break down silos. We have too many silos in academia, in government, across disciplines. We need to break those down, break down the silos between design and health, safety, environment, break down the silos between regulators and the research and innovation community to really have a successful program that really responds to society's needs and businesses' needs. Lastly, it needs to be transparent and trusted. So a program will not be successful. The technologies coming out of that program being adopted in industry will not be trusted if the program is not transparent, if there are not clear criteria, clear ways to measure whether those technologies are indeed safer and more sustainable. And then lastly, it needs to have big goals, a big vision, but it has to be pragmatic in nature. It has to take those small steps in the right direction, understanding that perfect shouldn't be the enemy of the better. Last slide. So I'm going to stop there and say this is a great opportunity in this sort of post-COVID green recovery to really put the resources necessary to build a program around new technologies that solves some of the most pressing issues society has, that moves us in a way that's economically beneficial, but better for health and the planet. Thank you.
Thank you very much, Joel, for this comprehensive overview, where you remind us that we have to keep a big vision, but we have to be pragmatic as well, so the good does not become the enemy of the better. And with that, I would like us to move to our next keynote speaker of today. From academic perspective from Joel, we move to the business perspective now. And I'm very pleased to introduce our next speaker from BASF, representing industry, I mean, one small part of industry, but still a significant player. We have Ms. Saori Dubourg, who is a member of the board of executive directors in BASF. So with that, I would like to invite you to show the presentation of Ms. Dubourg, and the floor is yours. Welcome.
Yeah, thank you very much. If you could put the slides on the first slide. So what we would like to show now in a few minutes is what do we think about sustainability by design. If you go to the next slide, please. If you look at the underlying paradigm shift that we are all facing at this point in time, there is a significant change, a paradigm shift between globalization and the next wave of growth, which is clearly linked to smart resource usage. The Green Deal is directly heading towards this new wave of growth, which will trigger more of a value than a volume growth alone. When we looked at the Green Deal, there are more than 100 new markets that are developing and that are triggered by the Green Deal. And this is very much in line with what we saw when we looked at the trends. If you go to the next slides, a couple of years ago already, when we formed our sustainability strategy, we asked 9,000 experts around the world, what are trends coming up? And if you look at good innovation, it's about being long-lasting. And that's why we were thinking innovation from the future backwards into today. So what do these trends mean? And as you see, all these trends are literally linked to the SDG targets, and they come at different speed and timing to their peak, even globally. Next slide, please. Now, if you look at how we structured our innovation, this is an example how we tried at making sure that good innovation is really environmentally friendly. So how do we make sure that whatever we do in innovation is sustainable? So we use literally 480,000 data points based on targets that are linked to cost saving and downstream, biodiversity, climate change, and so on and so forth. 60,000 applications in BASF have been structured towards these targets, and then we identified how many of our applications are already conform to these sustainability targets and which are not. We have clearly decided in our strategy that we will phase out those who are non-compliant over the next couple of years. And we have already structured this process of phase out. As you see, it's very important to have concrete criteria, as my pre-speaker said. If you go to the next slide. With this, we want to achieve also a new wave of growth, but it's not only about having sustainable products. As you know, in the discussion of plastic, for example, there is plastic that is already in the system. While we all agree that we have to reduce the number of plastic around the world and make sure that the waste is treated, I mean, chemistry is part of a solution pathway. So already 1.5 years ago, we made first testings out of household waste that we could decompose the molecules, because chemicals can not only compose material, it can also decompose. And with this, we were able for the first time to come to a liquid that can be fed back into the cracker and new products can be designed. So waste can be used in a meaningful way. What we need for that from structures is a proper waste collection process, but also the allowance that all methodologies can be used for waste frameworks and recycling. Today, only a few are really supported. And I think we need all technologies to make sure that waste streams are properly used. By the way, the CO2 level of this is very good. We made recently a study on this. Next slide, please. Now, it doesn't end at the recycling. It also goes into good innovation that begins with the end in mind. So we recently have seen a crossover of innovation and digitalization. So with a new fungicide called Rebisol, for the first time, we were able to optimize a product towards algorithms that really made sure that the environmental profile was far beyond what we knew in former products. So there is a huge opportunity field if you combine computational learning and machine learning with profiles that we need for more biodiversity, but also products that have an outstanding biological performance. Next slide, please. Now, if you look at this, this is not something we do alone. What you can see here is that good innovation needs by design a lot of collaboration, specifically with academia. So just naming a few, in California, we have a research alliance with big universities like Berkeley, also Stanford. In Asia, we cooperate with Beijing University, Tokyo University, and so on and so forth. It's a global network, more than 300 universities that feed their knowledge into our network. So it's the target, the strategy that designs the direction, but the knowledge has to be science-based. So whatever we do in the Green Deal, I can only advocate for a science-related approach to new innovation, because that will be very important. Science is rather slow in transporting information. Emotion is faster, I know that, but this is what will be an ingredient for the future. If you go to the next slide, please. Now, what we see is also a transformation in the way we steer business. And while Michael Porter already said that we will see more and more shared value between environment, society, and business, we believe the future is about creating systemic value if we understand that environment is the framework we are operating in, society the target, so business has to be part of the solution. If you go to the next slide, so we also calculated for the first time what's our impact across the entire value chain. 60 billion euro is generated in terms of profit for the entire value chain we create. What is interesting, Sustainability is not only about being green, it's about multiple factors that we have, also looking at wages, social dimension, and also the environmental impact. And this is where measurement criteria needs to be standardized, which brings me to my last slide. Now, in order to support this process, we have gathered an alliance of companies, which you see on the left-hand side. And we are very humbled because we are funded by the EU Commission with a LIFE fund to bring and support measuring methodologies to the green accounting standard that is driven by the EU Commission. And we're very thankful for a collaboration in that field, which is supported by academia, strategic partners across the world, standard setters, but also international audit companies. Because in the end, what we need in order to do this transformation is a new way of company steering, but this needs a joint common language. So I would leave it here. Thank you for your attention.
Thank you very much, Ms. de Bourg, for giving us the business perspective and also highlighting that it's about sustainability for both products and the environment, but it's a joint effort, and that we have to remember that impacts can be created along the whole life cycle, and there are good and bad impacts that we have to take into account, which calls for the standardized criteria. But with that, I think we are ready for the panel discussion. And I think we will start with our two younger scientists who will give a brief perspective. And as the first person I would like to welcome is Professor Victor Muschel, who's a professor of inorganic chemistry at ETH Zurich in Switzerland. His current research interest revolve around the transformation of smaller molecules, utilizing renewable sources of energy and following bio-inspired design. Please, Victor, the floor is yours.
Thank you very much, Ella. So I'm very glad to talk to you as a chemist in this sustainability by design session. As mentioned by the previous speaker, despite the sometimes bad image of chemistry in general public, I believe that chemists are problem solvers rather than problem makers in the context of achieving a more sustainable future. And chemists have the tools to analyze and provide solutions to the key challenges that are notably climate change, air quality, sustainable energy production, etc. And as an early career chemist, I realized that being able to better highlight and spread this view among general public is really essential to ensure that the youth still get involved in chemistry studies and job markets in the future. So I'd like to take the opportunity to be part of this session today to mention 3 points from the viewpoint of an early career scientist that I believe are key to maximize the efficiency of the transition to a more sustainable world. So first, and maybe foremost, is the importance of funding fundamental research projects, notably via the ERC. We need fundamental research not only to discover solutions to currently open problems such as carbon dioxide recycling, clean energy production, etc., but also, as it should not be forgotten, that academic scientists and professors are central in training the new generations of chemists in universities and technical schools. And the strong expected cut on the budget of Horizon Europe is, I would say, quite worrying in that context, especially for the younger generation, both as early career scientists and as students. The second point I'd like to mention is the need of platforms to ensure an efficient exchange between the different stakeholders in academia, industry, and general public. This is even more important for the young generation of scientists to which I belong, as we do not yet benefit from a strong network in industry, for example. And a European platform to initiate contacts between the Marie Curie training networks, the ERC grantees, and industrial R&D stakeholder would be really a great plus to maximize the industrial transfer of fundamental research and contribute maintaining this expertise in Europe. And last, I'd like to conclude on the will of the youngest generation of scientists to also get involved into the political discussion. The younger generation has been recently very active in voicing its will for a sustainable future, notably via the global climate strike and related actions. But beyond this demonstration, there is also a really strong will of young experts to be involved in advising policymakers on sustainable chemistry topics. And I'm convinced that expertise is not only a matter of age, and the youth can also contribute in a constructive way with a different view to scientific discussion. And however, again, I would say that there are very few platforms to today enable such an exchange between young scientists and policymakers at the European level. Thank you very much.
Thank you very much, Professor Millage, and reminding us that research cannot be done without funding, that it would be very beneficial if we had a platform established where scientists, businesses, and regulators can talk, and also a call for the younger scientists to be engaged and have a platform to engage with the policymakers. With that, we're ready for the next short presentation by our other young scientist. And I'm pleased to welcome Dr. Giovanna Millage. She acts as a team leader of the European Young Chemist Network and is dedicated to supporting young scientists globally. Please, Giovanna, go ahead.
Well, thank you very much for this kind introduction, as well as the invitation. It is a great pleasure to contribute to this important discussion. Sustainability by design clearly presents a critical strategy for long-term sustainability to become an integrated part of our society. And towards this goal, chemistry plays an instrumental role. So in this regard, I would like to weigh in from the perspective of a representative of the European Young Chemist Network, or the EYCN, with three complementary considerations that I would like to emphasize. Firstly, as pointed out previously, research innovation on materials and processes is essential, particularly as the leading technologies today primarily aim at high performances for a variety of functions, from our phones to even renewable energy technologies, such as those based on solar energy conversion and photovoltaics, that is the subject of my research. This still, however, involves non-recyclable and toxic components to meet these high performance requirements without long-term sustainability considerations. Even though a number of emerging technologies provides more cost-effective solutions than the current market leaders, they involve components that need to be replaced by more environmentally friendly alternatives. But to achieve this, more radical, innovative design is needed, and this requires fundamental research on materials and processes with long-term sustainability. Now, secondly, for these technologies to become adopted by our society, science communication is critical. The ongoing pandemic has particularly amplified the importance of science communicators in bringing science-based evidence closer to the general public, and our institutional frameworks should recognize their important role in outreach, as well as building trust in science, chemistry, and industry overall. So finally, and closely related, for science, innovation, and communication to be truly transformative, we need sustainability in education. And with this in mind, we have recently ran a survey at the European Young Chemist Network in collaboration with the International Younger Chemist Network and the Young German Chemical Society that is soon to be published, revealing that more than 90% of participating early career researchers need more detailed programs on sustainability. And most do not feel prepared to take on these topics within industrial environments, which we should consider moving forward with education models, funding programs, as well as enabling interaction with industry throughout education. Now, to conclude, achieving sustainability by design requires shifting our perspectives and strengthening or redesigning programs that foster fundamental research on innovative materials and processes for sustainable technologies, along with supporting science communication and sustainability in education, which I believe would bring us closer to the level of sustainability as an integrated part of who we are as a society, both locally as well as globally. And I look forward to this discussion. Thank you very much.
Thank you very much, Dr. Millage. And with that, we are ready for the panel discussion. And we have now heard from various regulatory, academic, and business side, as well as from the young chemists who are willing to challenge the way we're doing things today. And I hope that we are now in the panel discussion will give us and the audience some concrete examples and advice on which research, regulatory, and financial activities you think are most needed and who should take the lead in it. So with that, I would like to go to the first question. And let me ask you, Joel, Professor Tigner first. I mean, in the late lessons from early warnings produced at the EA, there's a long list of chemicals that led to widespread pollution and human disease because early warning signs repeatedly were ignored. Are there really ways we can design chemicals and materials better in the future, which will help us to make such mistakes again? Or will we continue to repeat our mistakes?
Great question. I think it's impossible to say we won't make mistakes in the future, but I think we can do a lot better learning from the lessons of past mistakes. The Late Lessons from Early Warnings report has a series of 14 lessons that can be learned from past mistakes. And some of those relate to ensuring there's adequate funding for evaluating the sustainability attributes of new technologies. We've learned even from recent technologies like nanotechnologies that when we build in sufficient, and that has to be sufficient funding to evaluate those sustainability attributes, that we're clear about them early on, we can prevent harm. There needs to be a multidisciplinary approach to evaluating these problems so that we bring in multiple disciplinary perspectives and multiple stakeholders to be able to identify problems early on before they happen. We need a better integration of knowledge from past events and current research and past research. So we need to use those new information technologies to bring together all of the knowledge we have to bear on a sustainability challenge. And then we need transparency. Transparency is key in information and studies so that they can be critiqued, so that we identify problems before they happen. As we've heard, we need better training where we bring together designers, those designing the new technologies, with those who can evaluate the sustainability attributes of those technologies so that we can bring together those aspects at the design phase. And then lastly, avoiding the lock-in of new technologies. So once we bring a new technology to market, if we're stuck with it, it's very hard if we identify problems to break away from it.
Well, thank you, Joel. These are very many concrete examples that actually summarize quite a bit what other speakers have said before. And you mentioned these attributes, and I suppose these are the things we would like to protect. And that brings me to a question for Ms. Millage. We heard several speakers mention the aim for circularity in Mr. Burke's presentation, for instance, and climate neutrality. But which are these other protection elements or attributes that should be included in the safe and sustainable by design criteria? Is it enough to have the circularity and climate neutrality?
Well, indeed, both circularity and climate neutrality are the cornerstones of the SSDG strategy. However, it is important to consider that they need to be integrated with functionality, as we have heard before as well. And what might be important to perhaps emphasize in this context is the need to also continuously assess these criteria in order to really identify and integrate all the elements. What does sustainability really imply in the context of chemical industry? From recyclability through toxicity, through the environmental impact and the energy costs, all these factors need to be considered and closely integrated, which of course necessitates a very holistic approach. And in this regard, it might be also worth considering reassessing the all risk assessment paradigms, particularly in the view of new technologies and materials such as nanomaterials, for instance, which also need to be continuously assessed throughout the life cycle, which I hope the current programs take into consideration with the appropriate mechanisms.
Well, thank you very much. This is a perspective showing here that we need to take not just one consideration into account, but several. And I would then like to ask you, Mr. Burke, coming from the industry side, I mean, of course, you're just representing one part of industry and there are many others in the value chain. But what are you or the industry doing to co-optimize your products and materials so that you both have taken these sustainability considerations into account, but also low toxicity? And are there certain materials that you're avoiding to use or based on concerns for safety and sustainability in the long run?
Yeah. So first of all, I think I know many companies in our sector that have a very diligent process of defining their sustainability criteria for their product portfolio. I think the key is to have equally sharp criteria also for challenge products. In our case, for example, it's very much linked to hazardous criteria of REACH, for example, but also tox profiles that we look at on a regular basis. And I think the industry has just recently renewed the commitment to the REACH framework, which is unique globally, where Europe is leading as a framework. For example, our company has registered more than 1,700 substances, and we spend more than 400 million in maintaining, the studies on toxicity, hundreds of studies, and a lot of people are working on this. Let me give you a concrete example from my personal experience, how I saw the follow-up, for example, in the field of agriculture on a very specific case, to make this a little bit more lively for the audience, what toxicity studies mean. So when I came new into the agricultural field, the team of researchers led me into a room with a water tub. And it looked empty. And I said, so what is this? And they said, oh, yeah, there's this little flea, water flea, E100 something. And I looked at this little water flea and I said, so what is this all about? And then they told me that since the 1970s, this is a water flea that replicates by DNA over time. And so it's the son of the son of the son, from a 1970s kind of water flea. And I said, what do you see with that? If this water flea moves differently and you can see slower movements, that's a clear sign that the water is impaired. So BASF, for example, is watching this single water flea since 1970. So there's a whole data series behind it, just to make this a little bit more lively. And that's the intensity that we are looking at criteria, because we are very aware that we have a huge responsibility towards humans.
Yeah, and this is good to know that you're considering different ways of testing whether the chemicals which get into the environment are actually causing effects, likely also for humans. I know you're also testing this. Good, but I think let's move to these points that were raised about the role of the scientist. And Professor Millage, you raised the point that scientists would benefit from a better understanding of the challenges that industry is facing. So based on your experience, which skills and education are needed in university studies to train the next generations of scientists in safe and sustainable by design? And are there ways that academic researchers better can connect with industry and understand these societal needs? And should it be academia or industry that takes the lead?
Thank you very much to bring these points that I believe indeed are key to illustrate what I just mentioned in the needs of platforms. So I'm sure that you will all agree that the best professors and teachers are often the ones that also have a practical expertise of what they teach. And we have currently in Europe, I would say, world-class academic research on the topics of sustainable materials development, for example. And as a consequence, I believe that from an academic perspective, these topics are very well taught. However, the connections with industrial applications may sometimes be lacking, as the industrial and academic communities are much more distant than I would say they are, for example, in the United States, I would say, as a personal opinion. And it implies that as most scientists and professors are not so exposed to the requirements of industrial partners, especially at the beginning of their career, this part of the teaching, the industrial part, is very likely lacking or being not so in-depth in many places. And regarding the last part of your question, it should, in my opinion, be neither academia or industry to take the responsibility, but policymakers instead. As if you take them separately, academic and industrial goals are not necessarily overlapping. They're not funded by the same type of funded. And I believe this overlap has to be brought by political incentive, providing the platform to enable or maybe even force that exchange and make sure that this occurs also in teaching.
Okay, well, thank you very much. I mean, we could continue this discussion all day. It shows there's a in the So do we have a question here for the speakers that we can see on the screen?
Yes.
And I suppose while we're waiting, I think we can take one last question. And oh no, here it comes. Where does Europe currently stand regarding extended producer responsibility and take back policies? How to counter negative planned? Something. Anybody who wants to answer to that question? Is that a guess, Joel, from your side?
I can raise it. I mean, certainly this is going to be a significant discussion in the context of the European Green Deal, particularly the part on circularity. Europe has done quite a bit around extended producer responsibility, for example, for electronics and automobiles, extending that to materials like plastics, etc., will be required to start thinking about this. Certainly, some of the member states have been doing more, like the German government, more extensive work on producer responsibility. But ultimately, I think as Ms. Duberg noted, this is the chemical industry is realizing that they have a responsibility to address this plastics challenge globally and find ways to take this material that's already out in commerce and reuse it for the more sustainable materials of the future.
Thank you. And I think we have one. Oh, yes, please, Mr. Borg. You raised your hand.
Yeah, I just wanted to add, if we want to make this Green Deal successful, I think, and this is what also some of the pre-speakers said, I think it will be important that this is a deal among all stakeholders. So industry, science, but also politics. And I think there's 4 to 5 criteria that are of utmost importance. Number one, sustainability is a super complex topic. So simplicity in implementation will be key. Number two, I believe, as I mentioned, the science behind this will be very important. And when we talk about producer transferability, this has to be thought through from a complexity point. So I think at the moment we see certain member states who have individual regulations here, but I think it would be very helpful to have more of a European framework because we need consistent criteria that we can apply. We have 70,000 suppliers as BASF. If every country has just 10 different criteria, you can multiply this in points, and we are easily coming up to 7 million data points that need to be checked against the law, which is getting very, very complex. And I think the most important is how do we manage the transition with timing for innovation? I think some of the speakers mentioned research needs time. And this is a dialogue where I would like to invite for an open discussion. Yeah, that I think we still need to lead.
Very much. I think these are very vigorous reflections, and you almost did the wrap up. We're coming to an end now, but as said before, we have taken your questions on the Slido, and we will look into these. And I think, Mr. Borg, your point at the end saying that we need a strong policy network and a strong policy framework to answer these questions and make the transition smooth is a good point. So with that, I would like to thank all the speakers, the audience, PG Research and Innovation for setting up this today, and we will continue with the Horizon Europe developments.